Questions? Questions that haunt you? Group 1, 2, 3, 4, 8. Any questions? Since I never meet you only once a week. Any question from the discussion? Good? Alright, nice. Okay, moving forward. So last week, we end our discussion at the category of architecture. There are 3 categories. We have software architecture, we have enterprise architecture, and then we have system architecture. So software architecture is the one that we are going to focus on for this particular semester. System architecture is basically the bigger design, the bigger architecture that comprise of 2 elements, the software architecture and the hardware architecture. For example, systems like for ATM machine, vending machine, factory, robotic arm, anything that involve a set of hardware where the software need to control those hardware. For example, like if you go to Proton assembly plant in what we call that, where was that? In UPSI? Tanjung Malim. If you go to Tanjung Malim Proton assembly plant, then you can see that the car will be the body of the car will go through a conveyor belt. Then it will stop at one station. So this station assemble the door, this station assemble the electronic, blah 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 blah. So there's a lot of mechanical arm. So that mechanical arm is controlled by software. So in that particular kind of system, you're required to do system design. But for the one that we do, okay, hotel management, e-hailing and whatnot, where there is no hardware for us to control, then we just do software architecture. Then the last one is called enterprise architecture, which has nothing to do with software development or hardware development. Enterprise architecture basically is just a strategy to use or to apply or to implement IT resources in order to digitalize or to digitalize operation of a company. That's all. So that's called enterprise architecture. So meaning that if I receive instruction from my boss, right? So right now we want certain function of the company to be digitalized. So as a IT head, for example, let's say I am the chief technology officer, I need to come up with a strategy on what kind of IT resources I need in order to implement my CEO instruction. That one is called enterprise architecture. So that was our discussion up to last week. Okay, so now let's continue the discussion to the importance of architecture. So why architecture is so important if it is just a drawing? Again, I would like to remind you, software architecture is not just about the drawing. It's about the decision that you make. Okay, why you choose that particular architecture and how you come to that decision. That's why architecture is so important. So number one, architecture is important because it will enable or disable the quality attribute that you want to achieve. If you choose the right architecture, then the software quality, the quality objective that you define in chapter 4 of your SRS can be achieved. But if you use the wrong architecture, if you choose the wrong architecture, then you will not be able to achieve the quality objective. Right? So what do we mean by enable and disable? Means that, enable if the decision is correct. Disable means that you choose the wrong architecture. So of course your quality objective will never be achieved. This relate back to the discussion that says architecture, not all architecture is a good architecture, right? A wrong choice of architecture is totally not a good architecture. So that is the concept. Number 2, reasoning about managing changes. Okay, reasoning about managing changes. Right, so when you have an architecture, basically what you do is that you have the ability to discuss with your team members either which part of the system that we want to change, which part of the system that can be modified. Right, so that's why we need an architecture. For example, like this. Let's say, again, I choose a 3-layer architecture. Okay, I choose a 3-layer architecture. Okay. So now I know this is my GUI, this is my logic, this is my data. So every time I want to discuss with my team, what are the changes that we can do, the discussion can be divided into section. It will not be just a random discussion, right? So let's say I want to do changes here in logic. Let's say this one particular software element, I want to do changes. But the best thing is that when you identify architecture, we can also see the impact of the changes. For example, like, will this particular component be affected? Let's say I have another component here, and this component communicate with this component. So will this component be affected? So that's why we need the architecture. But imagine if you dump everything in one structure. You put all elements here, right? Without any particular categorization or without any particular structure. So what happens that the discussion will be very difficult. Because what happens that without a proper rule and condition to control your decision, then you can make the communication become as free as you want. And imagine if you want to do changes for that particular structure, it will be very difficult, right? So that's why we need an architecture. Number 3, predicting the system quality. As I mentioned, software architecture is all about, software architecture is about quality, okay? Getting the quality value. Okay, getting the quality value. It's all about getting quality value. Right. So if I choose that, okay, for example, if I choose this architecture, automatically I can predict that, okay, I can achieve performance, right? I can achieve performance, and maybe I can achieve security. Why? Because this architecture is specialized for these two quality value. So I can give some kind of guarantee, some kind of prediction, what is the level of quality attribute that I'm going to achieve, right? 80%, 90% success or whatnot. Next, enhancing communication among stakeholder, right? Enhancing communication among stakeholder. And architecture also can be used as a communication medium, right? In tutorial, tutorial 1, question number 4. Tutorial 1, question number 4, right? Analysis. When you do a software architecture, right, the division will affect 4 parties, right? The stakeholder, the project manager, the technology, and you yourself. So the software architecture can become a medium of communication. A software architecture also will tell the programmer what will be the end product expected from their code. Let's say they write 50 Java code. What do I want to do with the 50 Java code? But when I look at the architecture, okay, from this 50 Java code, I can create 5 Java file, 5 software element. So that is a communication medium. So I don't have to tell my programmer vocally or verbally, or I need 5 Java file from that 50 Java file. Just by looking at the diagram, they already understand what they need to do. So it's a communication medium. Okay, number 5, carrying earlier decision. Carrying early design decision. So architecture become a very important basis for design. Whatever that you do in design must be within the framework of the architecture. It cannot break the rule of the architecture. So basically what happens that your design decision will become very consistent starting from the architecture until when you write your algorithm. It will be very consistent. The rule will be similar at any stage, right? So that's meaning that you're going to have a very strong system design. Okay, defining constraint on an implementation, improving cost and schedule estimation. Okay, this is also interesting. Improving cost and schedule estimation. Okay, because an architecture can help the project management to make a management decision, meaning that do I want to increase people, do I want to increase number of development day, do I need to increase budget, depending on which architecture that I chose. Okay, you may argue with me, how come planning was done like way before requirement analysis? Why do I need to revise my project management decision at this particular moment? Because at the end of the day, we want to choose the best architecture for the system. When I make that decision, there is a possibility for the management decision to be changed or to be revamped. Okay, for example, let's say I choose one architecture, but from that architecture, I need extra 2 people to do the design and also the coding. So then the project management maybe can assist or can take 2 people from another project and assign it to my project. That kind of thing. Okay, so that's what we mean. It can affect, improve the cost and schedule estimation, influence the organizational structure, so on and so forth. So these are the key importance of software architecture. Right. This is what I mean when I say when you make a decision on which architecture to choose, how does it affect other party in the software development project? So when you choose an architecture, this architecture will affect 4 parties. Okay, first, your project management. Number 2 is your client. Okay, next is the technology. And last one, yourself. Right, so when I decided that I want to use this architecture, immediately your decision will affect these 4 parties. Okay, so that's what this particular slide is trying to say, software architecture context. Okay, let's look number 1, technical context. Your architecture will affect on the decision what technology to use for your software development. Software architecture is independent of implementation. By right, software architecture can be implemented using any technology. Right, let's say I choose 3-layer architecture, means that I can develop that 3-layer architecture, or I can write code using that 3-layer architecture, using Java, PHP, React Native, blah blah blah. Okay, but then again, actually there is a study that say if I choose one architecture, that architecture can perform optimum using a certain technology. That particular architecture can reach its maximum potential if I use a specific technology. There is a study on that. Even though we don't force you to use that technology, but if you use that particular technology, then the performance of the architecture can be optimized. That's what we mean by when you choose an architecture, it will affect the technology that you choose. Okay, number 2, project lifecycle context. The architecture also will affect the project management. Alright, I asked this question during tutorial, and that's why I hate tutorial before lecture. I'm going to ask 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 8. What is the main thing that we discuss about when we talk about project management? Anybody from group 1, 2, 3, 8? When we talk about project management in software development, what is the key discussion? When you do requirement, this topic also appear. When we do software design, this also will be the main key discussion. My apology again that I cannot pronounce your name, so I just call you 1, 2, 3, 8. I'm so sorry. Or do you want me to call out names? I have your names. Right. I have your name. You want me to call out your names? Okay lah. Volunteer. Okay lah, let's start with the leader. Leader of team 1. Class rep. Team 1. Can you introduce yourself? Class rep. Tutorial group 1. You. Okay, good selection. Alright, my dear sir, what is the key topic when you talk about project management? When you talk about project management software development, we always discuss this particular topic, or this particular matter, this one particular issue, and that is human related. Other than that,
Budget.
Money.
Money.
Budget.
Money.
Since you mentioned the item specifically, as if you are saying resources and human are totally two different things, right? That's why I'm asking again. So when you talk about resources, so when you talk about project management in software development, the key things that always being discussed, that always being changed, modified, revamped or whatnot is the costing. Not really resources lah, cost. When we talk about cost, there are three items. Money, which is the budget, time, right, and also people. So when I choose an architecture, again, when I choose an architecture, my project manager need to revise on all these three items. Do I need to add more people? Do I need to increase more money? Right. Even though let's say the budget for the project is 250,000, right? And therefore design alone, let's say we assign, let's say 70,000 including salary. Right. But since the software architect say for this particular project we really need this architecture, there's no other option. The other option will make the system become problematic within 5 years, for example. Okay, so in that case, I need one more extra staff. So you need to negotiate with your project manager, right? You need to negotiate with your project manager. So that's what we mean by project lifecycle context. So basically, I just summarize the whole thing lah. I do not want to deal too much on this particular slide. Okay, next thing, when you make a decision on which architecture to choose, it will also affect the business context, aka your client. Your client give you a business goal, right? And this business goal is translated as quality objective. So what happens that when you choose an architecture, right? When you choose an architecture, can I achieve this or not? So that's why I said decision of an architect to choose and to construct an architecture will also affect the business goal. If you cannot achieve your business goal, meaning that your software architecture decision is invalid. You have made the wrong decision as an architect. Alright. No matter whatever that you do as a software developer, your client request, your client requirement must always be at the top of the decision chain. Right? You cannot simply make a decision just because I'm the architect. No, not necessarily. Remember when I said to the project manager, I really need this architecture to be implemented. Why? Because this architecture will help us to achieve the business goal. That's all. Okay? Right, go. And lastly, to self. Means that professionalism of an architect. The decision on your architecture will show the professionalism that you have. Let's say I want to use an architect. Let's say I am a person who is known among the software development circle as a person who always use the same architecture. Right? Why? Because all this architecture allow me to complete my project within time. That's true, but that doesn't mean that that architecture is the best, right? In some sense, I am an architect that doesn't want to improve. I am an architect that doesn't want to increase my skill set. Or I am an architect that doesn't want to explore other possibility for any kind of project that I develop. So in terms of professionalism, it doesn't really bring good things to me lah. Remember, software development community is very small, especially in Malaysia. We are very small. You make one mistake, people can easily recognize who you are or which company that you are from. Even though you close this company, you open another company, but the moment we see who's the founder, we know lah the quality of the project. Right? Big company, not necessarily only startup. There are big companies that is well known in Malaysia to produce a very crappy system. But the best thing about Malaysia is that, especially we have government project. How to get a government project? Through open tender. What is open tender? The government will issue you a requirement document that is called a tender document. So what you do is that you take the document, you buy the document for 200 ringgit, you go back to your company, and then you provide solution to all the requirement required by the government sector. Okay, for requirement 1, this is what we do, blah 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 blah. Okay, then we throw in a few candy, a few sweets to untuk ambil hati lah. What we do, free training in France for 2 weeks. Alright. Free maintenance period for 5 years. Now we throw in some candy lah to the proposal, and then next step we give the lowest price. Alright, government will never disclose this project is how much budget they have. No, usually they don't disclose. But usually, if a company manage to get a project from a government, usually they know what is the rough figure for every single project. Right. So in that sense, let's say why am I talking about this? Let's say I get a government project and then I fail lah. Let's say I total failure. Okay, the project doesn't go. Right. So what do? I open up another company. I appoint another director, but I am the founder. Right. So that company will try and get another project from the government, and since I know the trick to get the project, of course that new company will get the project. Fail again. It's okay, open up another company. that's the reality, because my wife worked for government, right? My wife worked for Ministry of Defense. Ministry of Defense. That's the most if you listen to what my wife, because my wife, when she was in Ministry of Defense, she's the head of the data center. The biggest budget will go to data center because all the servers, the VPN, the RAM. RAM there we don't talk about gig. We talk about tera, more than 10 ta. You're talking about that kind of size. Imagine how many millions of that. And happen to be only the same company always win the project. Right, because they know how to get the project. Okay, so yeah. So lucky lah, we as a software developer in Malaysia, okay lah. If you don't get project from swasta, you can still go to the government, no worries. Alright. So regardless of whether you're professional or not, you use the same architecture for the whole project, okay lah, up to you lah. Alright, cool? So don't do that lah, please. Oh yeah, by the way, as a software engineering student, you are bound to the rule of software engineering ethics. Have you heard about that? Right? I believe your lecturer have discussed with you software engineering ethics IEEE BSI. Right? How many pillars do we have there? How many pillars do we have there? How many key points as a software engineer you must follow? See? The last pillar. What is the last pillar? A software engineer must always engage in a continuous learning in order to increase the professionalism of the profession. Correct. Okay. I'm just saying. Question up to that point. So we have discussed the importance of software architecture and how does architecture decision affect the 4 parties involving in our project. So before we go to the third topic, any question? You wanna rest? Okay lah, rest 5 minutes. Okay, can I start? Right. So, architecture process. Architecture process is not a linear process. So, meaning that you don't simply get an architecture by having one discussion, one shot, and then, oh, I'm done. My architecture is already complete. We don't do that. Architecture design is a iterative process. Okay, it's a iterative process. Sometimes we need to do this again and again and again, reject, redo, reject, redo, reject, redo. That's quite normal in any software development project until you come to a point that everybody agree with the topic. Okay, then everything is okay. Right? So it is an iterative process. So the process starts from identifying the architectural requirement, then identify the design, then you need to validate. So the three generic, this is just a generic process. Identify the requirement, identify the architecture design, and then do the validation. Okay, architectural requirement come from your SRS. Okay, architectural requirement come from your SRS. So what happens that from your SRS you have two items, functional requirement and stakeholder requirement, right? But what we want is just your non-functional requirement and software quality objective. Okay, so your architectural requirement consists of two elements, the non-functional requirement and quality objective. Who's the team leader from group 2? Jihao? Oh, you guys, the leaders always sit together, is it? What, to show the line of leaders lah. So, okay, sir. You're from group 1. So, leader from group 2? No, seriously. Leader from group 2?
Maybe absent.
Class rep, group 2.
Maybe absent.
No wonder the decision on the lecture replacement class still cannot be solved until today. Group 2, leader, please. Okay lah, orange guy, come. What's the difference between software quality objective and non-functional requirement? No tips, no hint, no nothing. Aye, come on. Don't tell me you flush everything out from your SRE class. What's the difference between non-functional requirement and software quality objective? Software quality objective. Some books. Okay, I didn't say what I'm going to discuss is correct. Not correct lah. It's correct, but not the definite answer. But some books say non-functional requirement and software quality objective are similar item, are the similar things. But in my own understanding, these are two different things. So now, tell me what's the difference. I grilled group 4 to group 7 during tutorial, so I think I should let them go lah for the lecture. Right, so let's grill the other groups. My dear brother, orange guy. What's the difference between software quality and software non-functional requirement? My yellow brother behind the orange brother, get prepared. I will pass the baton to you. So the tema for today is color of your shirt. After the yellow, then we go to the lady with the black shirt behind the yellow boy. Then the brother with brown shirt behind the black shirt lady. No, okay, sir. What's the difference between software quality objective and non-functional requirement? Non-functional requirement? Alright, cool. Okay. No, lady in the black color is from my group. Brother with the brown shirt. Hi. Do you want to add anything to your friend's answer just now? He said just now software quality is maintainability or whatnot. Basically, he just listed the quality objective, but he didn't tell me what is quality objective per se. And then NFR is the constraint on the development project. That one I agree, totally agree. Do you want to add anything? What actually mean by quality objective? Okay lah, I'm not going to answer that on your own. Okay. Alright, I do agree. Your friend, thank you sir. So he said non-functional requirement is a constraint given to the project by the client. Okay, for example, law, anything related to legal constraint. For example, I always use this example. If you go to UAE or you go to Saudi Arabia, if you want to do anything related to encryption, encryption, they don't allow you to use any Western algorithm on encryption. They will ask you to use all encryption method and algorithm developed by UAE and Saudi Arabia themselves. That is a legal constraint. If you don't follow that rule, then basically the project contract will be cancelled. That is called NFR, non-functionality requirement. The client asks you to use .NET framework. That is also NFR. Okay. Software quality, like he listed maintainability, usability, and whatnot. But what actually is software quality? So I leave that for you to stick before you sleep tonight. So, in order for you to identify your architecture, I need input from these two documents. I need input from these two sections of your SRS. So this is called architectural requirement analysis. Okay? So that's what we mean by architectural requirement. So meaning that if people ask you, how do you choose your architecture? First, I need to identify the requirement. So what is the requirement? Non-functionality requirement and quality objective. Okay? Once you identify the requirement, then only you identify the candidate for your architecture. Or in other words, the second one, architecture design. Then only you do your architecture design. Okay, I'm not going to focus much on this. Why? Because I prefer to discuss about this guy. Okay, this is software architectural life cycle. So this is a much more detailed description about the architectural process. So the previous slide says that the architecture has 3 steps. Identify the requirement, identify the architecture, and validate. But from that 3 steps, we can divide them into 5 steps. So this 5 steps is called architecture life cycle. So this is from tutorial 1, question number 1. Okay, the first thing that you do is that first you need to do architectural analysis. In other words, you need to identify the concern, the requirement that you want to achieve. Everything must be based on your SRS. Okay, everything must be based on your SRS. So that's why if you make any mistake in your SRS, it will affect the whole development process. Starting from requirement, design, coding, testing, boom. Betul, habis. Okay. So, architectural analysis is all about identifying the requirement. So, once you identify the requirement, then we do architectural synthesis. Architectural synthesis is basically identifying candidate, the best possible architecture that can achieve the quality objective from step number 1. There are a lot of architecture available in the market, or the one that is discussed in books, in papers, that is used by industry people. So those architecture is what we call as architectural pattern. It's a template. It's a template, right? We have 3-layer architecture, we have N-tier architecture, we have pipe and filter, we have blackboard, we have data center architecture, a lot. But the issue now, each architecture is meant for certain quality objective. Each architecture each architecture is developed for a specific quality objective. So meaning that you have to identify which architecture that fit this particular requirement. Okay, which architecture that fit this requirement. Let's say when you do this, you identify 3 architecture that is suitable for the project. Now we go to the third action. This is where you identify the best architecture. Okay. Step number 3, architecture evaluation, is when you identify the best architecture from the candidates that you identify in step number 2. Okay, Mr. Rizwan, during my study, all the architecture is not suitable for my project. Can I create my own architecture? Yes. No problem. You can create your own. You can create your own design, you can come up with your own rule, you can come up with your own condition. No problem. No one will stop you because it is your project. But make sure your project can be validated. That will be step number 4. Meaning that people can understand your architecture, people can validate. Okay, if we follow this architecture, yeah, this quality objective can be achieved. If not, then bye-bye. Right? I'm not going to discuss much about customized architecture. That will be under chapter 2. Something that we will discuss either today or next week. Okay, next we will do architectural implementation. So once you choose your architecture, then you do your implementation. What is architectural implementation? First, there are 2 steps actually. First, you need to identify the structure. Okay, the structure is already identified lah if you use a pattern, something that is already available. Number 2, For those who are lost, currently we are discussing the fourth box. Okay, box number 4, architectural implementation. Then you need to identify the software element. Software element. So this task is actually under detail design. So basically, architectural design and detail design, it overlap a little bit. Okay, it overlap a little bit. Okay. Then you have your final architecture, which is the drawing. Right? So after you draw the architecture, you fill in the architecture with all the software element and all the communication, the rule, the property, the behavior. Then you come up with architectural maintenance. Okay, this is where you conduct review. This is where you do any adjustment or modification, right? But the most important activity here is to do review. Review means that you call all other party, all other stakeholder, your tester, your head of analyst, your head of programmer, everyone sit together, and then we discuss about your architecture. Okay, question: why didn't we do that here? Right. Here is a personal decision. When I do architectural evaluation, when I decide which architecture is the best from all the candidates that I have identified, that is a decision made between me and my team. Right? I'm not going to ask third party yet because I need to construct the whole architecture first. Then only I can conduct review. So here we do review. Let's say other people manage to identify some problem with my decision. So what we do, we can go back to architectural synthesis, or you can go back to architectural implementation, or you can go back to architectural evaluation. So this is why this process is iterative. Okay, it is a cycle. Go back and forth, back and forth, back and forth. It is not a linear process, one shot, boom, you got your architecture. Unless you are the architect, you are the designer, you are the analyst, you are also the head of the testing team. I ask myself, as a tester, is this pass? Pass. I ask myself, as a designer, pass. Okay, all pass. Right? And then the company is also yours. So nice, huh? Linear process, guaranteed, no worries. Right? Linear process. Okay? So this is not a linear process. Okay? This is not a linear process. Right. Class activity, no need lah. We don't need to do class activity. So basically that cover up the introduction to architecture. Who still don't understand what the hell is architecture? Raise your hand. Jangan malu. Okay. I rephrase my question. Who still have problem about architecture? So we have one. Would you like to share your concern with us? Which part that troubles you? The whole thing. No, seriously. Do you want me to talk to you? Do you want me to ulang now? It's okay. I can repeat again. No worries. Forget about them. I like that. Which part of the discussion that you don't understand? Good. Anybody else? Any part of the discussion starting from the definition of the architecture, the importance of the architecture, the context of the architecture, the element inside the architecture, the impact of the architecture, blah blah blah, up until the life cycle of the architecture. Which particular section that you want me to repeat? Again, we have 9 chapters, we have 14 weeks, no worries. Any questions? No. Want to do the second quiz? No lah, kidding. Right, another 5 minutes rest. Then we continue with chapter 2. Okay, chapter 2 is so important for your assignment. Oh yeah, by the way, I'm not the life cycle of an architect just now. This one. The life cycle of the architecture is basically the steps that you need to do for your assignment part A. I haven't released the paper yet, but to my group, I already explained them. But for the other group, I think just wait for Mr. Lim to explain it to you. My fault, I haven't released the paper. But what you do for your assignment part A is actually this thing. Alright? the life cycle of an architecture diagram or software architecture life cycle. Okay. 10 minutes lah. Okay, 10 minutes break. Now we are 7 o'clock. Come back at 7:10. Go and have a light dinner or whatever. Entry to the dinner. Come back at 7:10. Thank you. I understand, but what is the reason? What is the best way to tell people what is the reason? If people ask you what such is quality objective, then you can answer that. But if people ask you, I always tell them, if you understand something, imagine that you can tell that statement. Okay lah, up a bit lah, 8 years old.
Me myself also not understand.
I want to share something with you. When I look at this, it's quite interesting. Uh, look at the title of the position. Oh, I cannot make it bigger. Okay. Wahid International. Anybody knows what is Wahid? Wahid International is a AI-based investment advisor. Wahid, okay, it's a investment. It's an advisor that is already approved by Bank Negara. It is used worldwide. It is not Malaysian based. It's a US based. It's an AI based investment app. So you dump your money and then it will invest the money in all portfolio from US and whatnot, including Malaysia, whatnot lah. Okay, so this boy is the senior software engineer at that company. And then we have this lady, Natasha Selvaraj, the market data scientist for Informatech UK. Right, so anybody want to meet them? You can go to the event. So this event is open for all. Free admission on the 6th of March. Meet Malaysia youngest blah blah. Okay, you may get something from them. Go lah, go and join the event. And ask them what is software architecture. Their knowledge is maybe much more bigger than me, right? Okay, so go. I really suggest that you go to this event. I think it's a good opportunity for you to learn about what is going on. Okay. Wednesday.
Yeah.
Wednesday. So everybody want to go there?
How? 8 a.m. to 8 p.m. Our class.
Your class. I give cuti lah. I ask the dean, can my class go to the event? Anybody else want to go for drink? You still have 4 minutes to go. Yes.
When not enough, then take lah. Enough take lah. Still early, right? Yeah.
我右边，你看我右边。
可以去那边找啊。可以啊，可以。有的是。
The module is grouped by category, right?
No, it's a category of function. Right? Structure. Okay. Structure. If you categorize your structure into different components, so it's a category, right? But module is functionality. Function. You focus on function. For example, like this architecture. Right, this architecture. So this is category. What kind of category? This is GUI. This is logic. This is data. This is category. But module, okay, let's say I have what? Let's say I have user module. And then I have admin module. Right. So when I put enter this category, right? So okay, let's say for user module I have a lot of show. So any code related to GUI from both modules I must put under GUI. I don't care about the function, I care about the behavior. Right? So I have GUI underscore user, I have GUI underscore admin. So anything related to GUI I put here. The behavior, not the function. Yeah. We already discussed this. We discussed it in tutorial. Open back your SRE. Yeah, not the SRE. Okay. Right, now we go to chapter 2. If you look at this slide, it is chapter 5. In previous semester, we put this under chapter 5 because we would like to introduce to you what is architecture, what is design pattern, what is design issue and whatnot. But when I look back, the continuity of the topic is not really nice. By the time we come to this topic, some students already forget what is architecture. even though it's just week 6 or week 7, they already forget what is week 1. So before you forget, let's go and do this. So for this semester, we rearrange the topic for better continuity and better learning experience lah. So for this particular topic, there are 3 subtopics that we need to talk about. One is called software architecture structures, right? And then the architecture view, and lastly architecture pattern. So what does these 3 topics would like to discuss? First, we want to know what is structure. Alright, the definition of software architecture is a set of structure that provide reason. So now we want to understand structure. So in the quiz, I said structure can be a category, structure can be anything but not a module. Okay, so let's go deeper to that discussion. Then we go to architecture view. Architecture view means that how do you view your architecture, from which angle that you want to tackle that particular issue. And lastly, the most important thing is this, architectural pattern. So this is the one that you need to really understand in order to complete your part A of the assignment. So this is your main resources other than the one that you can find in the internet. The one that we are going to discuss in class are called classic architecture. Means that this architecture has been in existence for years long. Right? There are modern architecture like space-based architecture. There are, I cannot remember a few more. But modern architecture nowadays is more what we call as company company produced architecture compared to the classic architecture. Classic architecture usually produced by an academician, and then they presented in conference, and then the industry people use them. But nowadays the trend terbalik. Industry person is the one that introduce what they call as company-based architecture. For example, like space-based architecture is an architecture introduced by IBM. They are the first one that come up with the idea of space-based architecture. Then Microsoft last year they introduced a new architecture for their framework. But when I said Microsoft architecture, means that it was supposed to be. I mean, when you use the architecture, you must use Microsoft technology. But the behavior of an architecture, it must be independent of implementation. Meaning that if I take that architecture from Microsoft, implement it using another technology, can still be okay, can still be achieved. Okay, so that's the nature of an architecture. Right. Okay. So let's recap the definition of an architecture. Software architecture is a set of structure needed to reason about the system, again, which comprise of software elements. So inside that structure, so this is the structure, and then inside the structure I have software element, right? I have software elements, the externally visible property of those elements and the relationship among them. Okay, the property and the relationship among them. Right. So this, when we talk about interactions, there are many kind of interaction. We have pipe, client server, peer-to-peer, and whatnot. So we are going to discuss this in much more detail in this particular chapter. Now let's go to the first topic. What is actually a structure? Okay, what is actually a structure? So there are three types of structure that we can play around when you draw an architecture. So it can be module structure. But be careful, this is not module based on function module. Okay, let's say I want to develop restaurant management system. I split the system into two parts. User module, client module, admin module. From client module, I divide into a few more sub-module. Order module, payment module, blah blah blah. Admin module, I split it into a few more sub-module. That is called functionality module. Alright, in this case, we are not talking about that kind of module. In this case, we are just trying to say, if I have one big system, I want to split them into smaller structure, smaller part. So that smaller part is called a module. Alright, component and connector. Okay, there's another structure called component and connector structure. Alright, and then another one is called allocation structure. Okay, so this is the diagram. So from module, we decompose the module into a few more elements. So you can decompose to class, you decompose to layer. So that's called module. Meaning that, for example, like this. Do I want to create layer? Right? So instead of arranging my class in this manner, I want to arrange my class from top to bottom. That is called layer module. Right? We call it as layer module. Okay? Then we have component and connector. Component and connector, we have one center component that will control all the other components. So that's what we call component and connector. We will go in detail about this later. And then we have allocation. Allocation means how many team do I have? Let's say I have team in Australia, I have team in India, I have team in Kuala Lumpur. So what I do is that I create an architecture which can be divided into different teams. That one is called allocation structure. So it means that when I want to make a decision, when I want to create my own architecture, there are three styles of architecture that I can choose. Module based, component and connector, and allocation. So now let's look one by one. Right, I give you 1 minute to read first, then I give you the summary. By the way, this is not my slide. No, I inherit this slide, but I don't have time to revamp it to make it easier for you to read. Basically, when you read this slide, as if like you read the whole book. So it's good lah. Just that too many words, that's all. Okay, so read this 1 minute. I know that you haven't opened this slide, so just read it first. Then I give you the summary. Okay, now, so in this case, okay, what is module-based structure? Module-based structure meaning that I have one system, right? So I think to myself, what category of sub-component that I can create? Okay, let's look at this part. Okay, let's look at this. Okay, this is called a three-layer. Sorry, this is actually layer architecture. But okay, let's say from module perspective. Okay, I have one big system. Okay, from one big system. Okay, because I do not want you to get confused with the module in the system. That one is functionality. Okay, now let's say I have one big system, hotel management system, right? Functionality. I have admin. I have client. Okay, from admin, I have HR, I have check-in. Oh yeah, I have front desk. I have front desk. I have housekeeping, blah blah blah. Client, I have order. I have booking. I have what else? Payment. Your favorite module. Blah blah blah. Right, those are functionality module. Okay, but as an architect, my question will be, how can I split this into category? So this category is module. Is the definition of, not definition of module lah. The simpler way to tell module. In the quiz, when I said module, I refer to functionality module actually. I should have put the word functionality module. So my bad. Okay lah, free mark for that quiz. Right. So that's why the category is called module. Okay, what do I mean by this? Okay, from the hotel management system, what can I get from it? Okay, I can have GUI. One module I can have is GUI. Right. Everything is about GUI. The one that can be seen from the user. So after the user enter the system through the GUI, what will be waiting for them? Logic. From that logic, what will be the next step? Data. So this is called module structure. Okay, I give you another example. Library system. Okay, let's say I have library system. Right? My aim is to make sure that data can be accessed easily. Okay, easy access to data. Easy access to data. Okay, that's my aim, for example. So now, how many so-called category that I can identify from this system? If you are not careful, you're still going to say GUI, logic, data, because that's what you are familiar with, right? GUI, logic, data, right? But actually, if you look differently, I can do something else. Okay, library is a very, very big system, right? It has a very big repository. Library has a very big repository. Means that the data is so big that if I want to search one particular data inside a library system, it will take a very long time. Right. So what does it mean? If this is my data, how can I make sure every component who want to search the data will have a very short transaction time? Right. What will you do? What will you do? What will you do? how many category of item that you can identify? So the first category is data. Okay, same here lah. Okay, data. Then what? Then what? Logic. How many group of logic do you want to create? Okay, like hotel management, I just need one category of logic. But for this one, I said I want a very fast. Okay, the time taken to search for one data in this big data is so high, meaning that any transaction outside the data must be low. Meaning that I cannot have one logic. Everybody come here and then enter the data. That will take a very long time, right? So what I do, I create logic, and logic. So I split the logic into a few categories. Compared to a hotel management system, every transaction will go through only one group of logic. But for the data, for a system that have a very huge data, where data transaction will take a very high amount of time, so I need to offset. Offset means that if the data transaction is high, meaning that the processing must be low, right? So that we can still achieve a good performance. So in that case, I need to have multiple logic structure, so that the entry can be from any section. Okay, another scenario. Every end of this month, the last day of every month, TAR UMT will do two things. One, generate the pay slip of every staff. Number two, transfer all the salary to individual bank account. Right? But in order to generate this pay slip, we are going to do a lot of processing. First, we need to cut some money for tax. Next, we need to cut some money for EPF, for pension. Then we need to cut some money for accident, so. So meaning that before TAR UMT can generate the payslip, there are a few process that must be done step by step. Then only they can generate the payslip. Then only they can bank in the money. So in that case, what category of item that you can create? What category or what module can you identify for that particular system? Crick. I really want you to understand this. This is structure. This is called this module-based structure. Module-based structure. Meaning that if I have money that I want to give to my staff, I need to process it, right? Process number one. Okay, process number one, cut tax. Process number two, cut EPF. Right. So what is this? This is process. So similar to this lah. I need to have multiple logic, because each logic will be done in sequence. I cannot just have one box called generate slip. It doesn't work like that. How to make this easy to understand? Based on the face reaction, totally lost. Let's move on to the next slide. Hopefully, the next slide can give you more information. In a large project, module can be subdivided based on the theme. Okay, we can also divide the module, or we can create structure based on theme. We have the database theme, right? Or we can decompose based on object-oriented analysis and design principle. Okay, module-based can be decomposed. The units are module related by the is a submodule of. Submodule. Okay? Or you can use users. The units are module, procedure or resources on the interface of module related by the users relationship. Users. Logic uses data. Logic uses data. Logic uses data. Users. Or you can say by layer. When the users relationship are controlled in a particular way of a system, a layer will be emerged. And that layer usually coherent to a set of related functionality or behavior. This is called layer. GUI, go to logic. Logic, go to data. Layer. Alright? And then we have class or generalization. The module units are classes and the relationship is inherent. We can also do that based on some kind of inheritance principle. Means that I have one big logic and then I have sub-logic that inherit from the first big logic. So that is called module-based structure. In other words, you need to identify how many category that you want to create in your system. How many category that you want to create for your system? No. 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 Okay. On this side, no. Anybody else have problem with that definition? Module. So it means that when I want to create a software architecture, first thing, if I want to create a structure, one concept that I can use is called module structure. What is a module structure? Any category of item. Any category of item that have a certain behavior. And that behavior can be replicated. Replicated means, for example, like this one. These are all logic, but each logic process different thing. And then they sit around the data. In this case, I only have one logic. In this case, I have multiple logic, but the logic must be run in sequence. So for each project that you do, you need to understand what category of things that you need to achieve. What category of behavior that you want to introduce. Behavior means what to do, what the unit do, what the module do. I have GUI, so every code related to GUI, every module related to GUI, I put under one category. GUI, logic, data. Or logic, data. Or I can have data, logic, but in we call it as a linear process. Yeah, I'm failing this lecture. Okay, fine. Okay, repeat. It's okay. Let's see. Let's go to the second one. Another one is called component and connector. Let me think of something. Then I'll share it with you next week if I can summarize it in a better way. Alright. Next one is called component and connector. So structures are dynamic, focusing on how elements interact with one another in real time to carry out the system function. Assume the system will be designed as a collection of services. Another type of structure commonly used to characterize system is the services, the infrastructure they interact with, and the synchronization and interaction linkage between them. I really need to change the slide. Okay, now I can also identify structure based on this. Who is the service provider? Who wants the service? This is maybe easier. If I can create a group of item and that item provides service. And for example, client server. This one I think you can understand. Anybody don't understand what is client server? Okay, when you use intranet, what is the client? What is the server?
Client outside.
Boo.
Client.
Guys, okay, I generalize. In a web-based application, what is client? What is server? What is client? What is server? Mobile phone is the client. No. The browser is the client. What is the server? Server lah. Yeah, true. Literally, server is a server lah. But what server is a group of software that you put inside the server in order to receive whatever request coming in from your browser. For example, you want to log in, so your browser show you a login page. That is called a client. When you enter your ID and password, when you press submit, I send a request to another software inside the server. I want a verification. Please check either this ID and password match. So the software inside the server will process that request and then return a value, yes or no, success or unsuccessful. So that structure is called client and server. So that structure is called component and connector. Who is the component? The client or the server? There on the slide. So the client is the component. The server is the connector. Why client is component? Because they are the one that request for something. Connector is the one that receive and provide result. So we call it as client and server. Okay, actually this idea come from UML, from object oriented design. Okay, this is for chapter 5 actually. When you draw a component diagram, okay, let's say I call this login validation. Login how to spell validation? Validation. Okay, then I have another component. Okay, I call this as login underscore GUI. Okay, let's understand this. So login.gui will be run by client. Who is your client? Browser. So this component will be run by browser. Okay, this component will be run by your server. So that's why we call this as server, not your local machine. It's a server. Okay, now I want to log in, so I request. So when you request, the diagram will look like this. I request. wait. Oh, no. I request. It's a crescent moon, half circle. I request, right? Request, right? Half circle. For those who cannot memorize, when I ask for something, your hand will be like this, right? Mr. Rizwan, be my supervisor. What is my response? Right. I provide supervision. Okay, now I request for I want to log in, but in order to log in, it must be verified. So somebody must accept the request. So this is called connector. So this symbol, the crescent moon and the ball, is called component and connector. This is where this idea come in, right? Meaning that when you create your structure for your architecture, the way you think is like this: who wants service, who provides service, who wants service, who provides service. So if that is your mindset, you are using component and connector structure to make it easy for you to understand. Alright, so component and connector structure means that the way you think about your architecture is which group of software element will become the client, the one that requests for editing a lot of things, and which group of software element that will become the provider that will provide the service. So if that is the way you think, that is called component and connector structure. Module structure, if you think like this, what are the category of behavior that I can create? GUI, logic, data. Logic, data. Data, logic, data, logic. So if that's the way you think, means that you try to arrange the position of all the element, that one is called module structure. Okay, it's okay, no worries. Moving on to the third one. Okay, this one is the easiest one, allocation structure. In other words, if you discuss your architecture by asking one question, who will do this part? Who can I give this task to? Okay, let's say I have one system, I create one architecture, then that architecture, let's say, have three structure or three boxes. One box will go to India, one box will go to Australia, one box will go to my team in Singapore. If that's how you think, mean that you divide your system based on the group of implementation. That is called allocation structure. You allocate, you assign tasks to somebody. That is called allocation structure. So in other words, software architecture, when you want to develop an architecture, when you want to make a decision what architecture is the best, you can think from these three different views. Module or behavior. Number two, who requests for something and who provide the service. Right? And then number three, allocation. How many team do I have and what they will do in the development process. That one is called allocation structure. Okay. But at the end of the day, an architecture usually is a combination of all three: allocation, module, and component and connector. Right? Usually when we talk about architecture, usually we combine all these three different point of view or these three different concepts to become one architecture. Right? Because it's quite difficult, when you want to develop a system, if you only focus on one group in India, one group in Australia, one group in Malaysia. So I give them, you do this, you do that, I do this. But how to connect? The moment you discuss about connecting the component, then it becomes module based. But when I connect the component, for example, group from Australia requires data from group from India, then it becomes component and connector. India is the provider, Australia is the service requester. Correct? Make sense? So an architecture is actually a combination of three different point of view. Three different point of view. Okay. I'm having a hard time right now. Okay, cool. Alright. Structure represent the primary engineer. Okay. At the end of the day. Okay. Look at this particular summary. each of these structure provide a different perspective on design that handle the system. Each is valid and potentially useful on its own right. However, they are not independent but highly interrelated. Often the module structure is dominant but not always. So meaning that when in an architecture, most of the time we will describe the architecture from module perspective. But actually the architecture also have control and connector and also allocation. So not all system warrant consideration of many architectural structure. The larger the system, the more dramatic the difference between this structure tend to be. So depends on the project. Not all project requires you to have all the three structure, but most of the time we will combine all the structure to become one architecture. Alright. Okay, I'll give you one simple example lah. Okay, come I'm not sure whether this can help you to understand it or not. Okay, now, first step, I identify the behavior. How my system will be. Okay, I want to build a house. Okay, let's try this. I want to build a house. I want one section for me to sleep, one section for me to work, one section for me to cook, one section for me to clean my body. What is that? That is called module base. Are they functionality? No, they are not functionality, because if I want to sleep, what do I need to do? I need to change my clothes, I need to switch off the lamp, blah blah blah. Those are functionality, correct? Those are the things that I need to do. All those things are human-based activity, right? So means that I need to identify the space. Right? I need a section for me to sleep, for me to do my work, for me to cook, for me to wash. That is module. That is module. Okay, but then again, let's say after I wash my, after I take a bath, I need to go to my room. After taking a bath, I need to go to my room. Right? I need to take my clothes or whatnot. So in this case, I need to have a connection between my bathroom to my room. Now it become control and connector. Are we good? No. Okay, fine. This is my GUI. This is my logic. This is my data. By doing this, I already implement module structure. Okay, now I include some rule. Okay, now I put some rule. What is the rule? Everything that the user requests must go through the GUI. And then the GUI, whatever inside the GUI, cannot do any process. Cannot do any processing. So this part only receive data and then return data to the client. He don't do any process. Then who will do the verification? Okay, let's say the data that come in is ID, password. Who will verify? Verify is here. So GUI need to connect to logic. So what am I doing now? Component and connector, Mr. Rizwan. So that is component and connector, right? Component and connector. So who is my component? This is my component. This is my connector. Why this is the connector? Because he is the one that provide the service. He is the one that will do verification. Who requests? I am the one. Please verify this. I do the verification. So now I have my module, I have my component and connector. Okay, now where does the allocation come in? So once I create the architecture, same goes. When I want to do verification, I need to connect to the main database. So now this become component, this become connector. Right. Then once I create the design, then when I pass it to my designer will tell the team, okay, GUI, I will pass this to the front end team. For the logic and the database, I pass it to the back end team. That one become allocation structure. So that's why an architecture consists of all the three different views. Identify the behavior, identify who provide the service, who request the service, and identify who will implement the structure. So you have three. Right, questions? No question because no, seriously. I really want you to understand this. Questions? Okay, go home. I want you to read the slide and ask ChatGPT to summarize it. So if you still cannot understand what ChatGPT say, come back to me. Alright? Okay. Questions? Right.